So let us start with first chapter, number systems. How many times they will teach us number systems? We are teaching numbers from grade 1. In grade 1, they told us 1, not grade 1. In fact, when we were 2 or 3 years old, they start teaching us 1, 2, 3, 4, and so on, which we later learned are nothing but natural numbers. We named it as natural numbers. But then they said natural numbers are just not enough and introduced zero to it. So our previous thing was there, it's only there was an extension of zero to it. And we called it as whole numbers. After whole numbers, what? They said even positive whole numbers are not enough. We need negative numbers. And what they call negative numbers as? Integers. And after integers, what? They said we can't deal with just wholes. We need fractions. We need rational numbers. And in rational numbers, we have both negative and positive fraction. These are not the only fractions which are possible. I am writing only few. For example, minus 1 by 3 minus half, and all these are rational numbers. But now we are saying even rational numbers are not enough, and we are introducing a new number system to you, real numbers. And real numbers is again extension to rational numbers. Real numbers have two parts, irrational number and rational numbers. So whatever previous thing was, what we noticed is part of the new system extended. Like natural numbers was part of whole numbers. Natural numbers are inside whole numbers. Then whole integers also have whole numbers in it, and we had extension of only negative numbers. After integers, we said even integers are part of rational numbers. And now we are saying rational numbers are also part of real numbers. So my real numbers have two parts. What are they? It is rational number and irrational number. Now what is irrational number? Rational numbers I have done. My full first chapter was nothing but rational numbers only in 8th grade. So now real numbers have two parts. One is rational numbers, as we just discussed, and second is irrational numbers. Now, if I say, what is my half? Convert it into decimal. What you say? This is nothing but 0.5. If I say, convert 1 by 3 into decimal, what happens? Just see. If I divide 1 with 3, I will put a decimal because it's lesser. Point decimal up also. 10 and 9 comes again 1. So I got 3 here. Again, I will write one more 0, 0, 3. And it keeps going. There is no end to it. And because every time remainder is same, it will keep going. So rather than writing like this, what we do, we put a bar. Bar means these three keeps repeating. We keep the bar only on those digits which repeats. Like, suppose let me show you one more example. 1 by 6. Now 1 by 6 is what? If I divide 1 by 6, see what's I'm happening. Put a 0 here, put 0 here, 0. I get 1, 6, 4. Now I will put 1 0 more and it is by 6. So 36. Again I get 4. Then again 6. So first digit is not repeating. It's only 6 which keeps repeating. So how will I write? I will put bar only on 6. Because 1 came only once. It's 6 which is getting repeated. Now these kind of numbers are irrational numbers. No. Even these are rational numbers. Because 1 by 6 I know is in P by Q form. And where q is not equal to 0. And I know that where all the numbers in form of p by q, where p and q are integers, q not equal to 0 is nothing but what? Rational numbers. So there are two kind of rational numbers. What are they? They are, one is terminating. Like this one, if we see, this one was nothing but terminating. Terminating means stops. When I converted this into decimal, it stopped at point 0.5. Now, second thing is non-terminating. Non-terminating means which does not stop. Right? See, it kept going. No, so many threes came. Right? And there is no end to it. If I keep dividing it, it won't stop even if I do it thousand times, million times. But it is recurring. Recurring means the same digits are repeating, reoccurring, you can say. So, what are rational numbers? One is terminating, second is non-terminating and recurring. Now, what is irrational numbers then? Have you ever, all of us has learned what is, how to find square root of 2. Right. So if I find square root of 2, how we do? We have done long division method in 8th grade. Same I am going to do. 0, 0. Let me put few 0 in pairs. So 2, the perfect square greater than 2 is 1. And then if I put 1, 1. Now, since I am bringing the first pair after decimal, I will put decimal here also. So what I will do the double of 1. So it comes, here comes 2, 4, 4. 4 fours are 16, 4 to the 8, 96, again 4, then again I will get one pair down, double of it, 280, so 281. So if I do, I will see, I can keep doing it, just a minute. I will keep doing it and it will keep going. There won't be any end to it. Plus, there won't be any repetition also. Like, because it is a non-stop method, it will take lot of time. Let me show you in calculator. Calculator, let me open the calculator. Where is Mr. Calculator? Here comes Mr. Calculator. And let me do square root of 2. So see, so now here it is stopping at 5. It has done rounded off because space has got finished. There is no further space. If there has space, no, these digits will continue even for 1 kilometer, even after that. So, and see, there is no repetition of digits. So, these kind of numbers which doesn't stop and doesn't repeat are irrational numbers. Okay, so let me write. I have showed you also. The irrational numbers is nothing but numbers non-terminating, non-terminating and non-repeating. I hope I have made you clear what is rational and what is irrational.